Have you ever wondered how big games save your data? If you have, then this video is perfect for you. As many of you might know, when you first start programming and you decide to make a game inevitably, you may try to save your data as a JSON or just text file, anything like that, and it works until you update your game. When you update your game and you add new data and new fields, everything can break. That's why big games use binary files. Binary files are fast, tiny, and you control everything. A binary file starts with a header. It's like a label on a parcel. It tells us three things. Is this our file? What version of data is this? And how much is in here? We're going to be using an example that I wrote on GitHub that you can find here, this link which I'll leave in the description. And this will cover everything we're going to be talking about today. So, to start off, as you can see here, we're saving it all in a struct. How do we actually write this to a file? Well, we have some helper functions here. And in these, what happens is we simply just write to a file directly. So here we have our version 1 to save version 1. Give this a pointer to the data. We give it a count and the file to write to. Obviously, if the file isn't open or doesn't exist, we don't do anything. But if it does, we write to it. We write the data, the size of the struct, so the size of this. Tell it how many of these, and the file we want to write to. It's simple as that. And then when you're ready, we can reload it. So the way that loading it works is, if you see down here, we have get header. That's how we find out the information. So we look inside our file, we create a new header. We jump to the start of the file just to be safe. Then we read all the data into this new variable. We tell it how much information to read, so the size of the struct. There's only one from our file. And that will now tell us everything that we wrote before, such as the version, the identifier, and the count. So let's dive into how this program actually works. So, this just makes sure there's enough arguments, which is, this would be 1, this is 2. So then we try to open our save file. If it doesn't exist, then we create one in binary mode. So this is write binary, this is read binary. We give it a new header with version 0 and count 0. This lets us know that it's new and needs setting up. Now we can safely close it and re-enter read mode. Now we read the header and we just check if the identifier matches up. So in our case it's save, as you can see here. So we check if this magic identifier is the same as this, which if it isn't, it tells us it's not ours and gives us the information that we need. Exits out. But if it's correct, it'll tell us what version it's loaded in. If it's new, it says 0. Now we stop reading. Now we just make sure it's in boundary. So in this example, we only have from version 2 to 0. That's what we're checking there. Now we say if they want to load data, they need to read. So we open it in read mode. Again, if it isn't there, just back out. Now we check our header information, which we grabbed up here. Now what we do is, if it's version 1, we load version 1. And we just print it out so we can visually see it. If it's version 2, same thing. If it's saved, we open it in write binary mode. Now this is where we check if it's a new file. If it is a new file, then we say, oh, what version, 1 or 2? And then we take it in. And now we ask them how many they want to create and put it into this variable count. They make a new header because now we have the information that we need. knowing there's going to be this amount saved in the file and the version that we got up here. So now here we create an array of play data version 1, which is done by allocating the size of our data struct times by the count. And now we can set up the data. In this case, we're just reading straight from the terminal. So we ask for a name, input the name, ask for health, input the health. Now we just write the file. Just like what we're showing here, this is what's happened. This is all that happens. It just writes the data, just like that. Same thing for version 2, we get all the info we need and then just write. Okay, so let's show the functionality of this. So to compile, you just want to run this, and we'll just output as binary saving.exe. Now we'll get some warnings, but we can ignore it because it's just an example. Binary saving, so we want to run it. And it'll ask us how we want to run it. So let's save, since it's our first time using it. So we'll save. We'll save as version 1. We'll create 2 players. Create John, 100 HP, and we'll create Ben, also 100 HP. Now we can run the same thing, but with --load to see our data that we wrote. Now you can see it in the same order. Now, let's say we've now updated our game. Now we're on version 2, which has a level. If a player does try to join the game, it will break their data. So this is where the header's functionality comes in. So, let's say if we need to migrate the data. So firstly we read, we ask for the version they want to migrate to. If it's the same version, then we can just ignore it. Otherwise, we can take our old data by loading it, then we migrate. So the way that migrate works is to take the old data and the amount, create some new data, or we create the array ready to hold the new data. Then we go through and we set the properties. So we set the health to be the same health. We copy the name over into the new name. If we're migrating backwards, we don't need to copy over the level because it doesn't exist in this version, so we can ignore it. However, if we are going forwards, which in this case we are, we have to give it a level, which it doesn't have a level saved. So what do? We give it a default value, which you can see here. And then once it's been migrated, we close it from read mode, we open it in write mode, we set the new version, we write the header again. So you always want to write the header first, as that is what you want to read first. Once that's been written, we add our new data, and that's it. The same process is repeated here for backwards compatibility. And this is just some errors, and then we just clean up at the very end. If it's still open, just close it. Okay, and some important notes which you can see here. So this first one basically says that if you try to add a pointer in the struct, so in here, if this was like this wouldn't work, because that would only save the address, not the value. So then when you restart your program and you try to load again, even if it's the same version, it will just point to an address that doesn't hold the value anymore, and it will corrupt the data. Now the second and last note here is that saving data this way isn't secure entirely, or at least in this format. Now most big games such as GTA 5 and Rust, they use methods to encrypt the data further to avoid people going in and altering it. Now in this example I haven't done any of that, I've wrote it completely raw. This is because it's just a simple example and doesn't need it. But in your use case, you might want to encrypt it if you don't want players tampering with it. So now let's see our migration. So let's say we want to migrate. It recognizes the version. When it's loaded to 1, it's already 1. Now, if we'll migrate to version 2, now it will just migrate it for us. Reload it, and now we can see they have the level. Same order, same health, but now they have a level. And we want to migrate back. You see, level's gone, everything's fine. So yeah, that's the whole secret behind game saves that don't break with each update. Just a simple binary file with a little header. If you want me to go deeper into binary tricks like packing flags into a single byte or bit fields, let me know. I do have some fun future stuff planned. Anyways, thanks for watching. Peace.